Good morning to all. Myself Professor Archana from IIT ISM Dhanbad. We are in course of Introduction to Python and Petroleum Data Analytics. So we were discussing data wrangling and pre-processing. So in the last discussion, I talked about working with missing data in pandas where we are using this as part of a data cleaning. We are using how to handle the missing data in Python. In the today's discussion, we are going to discuss about the outlier, detecting outlier, where under that first we will be understanding the box plot, moving on z square, and then interquartile range, and then finally the scatter plot as part of the outlier. So starting with this one, detect and remove the outlier using Python. So the Python part we will come later on in the next class. So today first we will be knowing what is outlier. We'll start with that one. So outlier are the data point that deviate significantly from the other data points in a data set. So they can arise from variety of factors such as there may be the measurement error, maybe there is a natural deviation in the data. If left unchecked, it can distort the data analysis. So we require to handle the outlier and skew your statistical result and impact the machine learning model performance. So if we are not handling the outlier, it is leading to distorting your data analysis and another issues along with that. In today's discussion, we are going to focus how to detect and handle the outlier. So first, we will be starting with what are the common causes of outlier. Understanding the causes of outlier helps in finding the best approach to handle them. So some common cause we do have measurement error. So under this one, error during the data collection or from instrument, it can result in extreme values that do not reflect the underlying data distribution. So this falls under the measurement error. Second, sampling error. So outlier can arise if sample we collected is not representative of the population we are studying. Then the other causes we do have the natural variability. Certain data points naturally fall outside the expected range, especially in data set with inherently high variability. Then next, data entry error. So sometimes mistakes made during the manual data entry such as incorrect values or typo can create outlier. Then another type of error, there could be the experimental error. So outlier can occur due to equipment malfunction, environmental factor or unaccounted variable experiment. Unaccounted variables in experiment. Sometimes sampling from the multiple population also causes the outlier. So combining data from distinct population with different characteristic, it can create a outlier if researchers don't properly segment the data properly. Sometimes there is an intentional error. So this intentional error, sometimes it is a beneficial. Why we go ahead with the intentional error? Sometimes outlier are deliberately introduced into the data set for testing purposes to evaluate the robustness of the model or algorithm. So these are the common causes which lead to the outlier. Now next, need for outlier removal. What is the need? Outlier can create significant issue in data analysis and machine learning, which makes their removal important. So already we have that it lead to skewed statistical measures, then reduce our model accuracy, and then we can have the misleading visualization of the data. So under that, now we get what is outlier and what causes the outlier. Now the first thing in the today's discussion, we will be talking about the box plot. Then we will move next. In the today's discussion, first we will start with the box plot. So box plot is a graphical method to visualize data distribution for gaining insight and meaning the informed decision. So the box plot is a type of a chart that depicts a group of a numerical data through their quartiles. So first we require to understand what are the different components of the box plot. If we are discussing about the box plot, first we should be knowing what are the component of the box plot, how to create a box plot, uses of a box plot, and how to compare the different box plot. So this box plot, if we call it, is also known as a whisker plot, box and whisker plot, or simply box and whisker diagram. So box plot is a graphical representation of the distribution of a data set. So it displays key summary statistics like we have the median, quartiles, and potential outlier in concise and visual manner. So when you do have a data and we want to check what is the outlier inside the data, how many data points are outside the range, or we can consider it as a outlier, we can use the box plot to find that one. So first we require to understand it. Okay, so this, by using the box plot, you can provide a summary of the distribution, identify potential, and compare different data set in compact and visual manner. Okay, so talking about the elements of the box plot, so a box plot gives a 5 number summary of a set of a data. So one is the minimum, then we do have the first quartile, that is represented by Q1, then we do have a median, that is a Q2, then we do have the third quartile, that is a Q3, and then we do have a maximum. So these, all this we will be talking one by one. So talking about the minimum, so the minimum is the value in the data set excluding the outlier. So when we calculate the outlier, so outlier we are not taking as part of the minimum. So minimum is the value in the data set excluding the outlier. Now talking about the first quartile, it is the 25% of the data lies below the first quartile. Okay, so that is we are representing by Q1. Then we do have a median, so it is the midpoint of the data set, and when we, it does depend, we do have the even number of the data or we do have the odd number of the data. So when we do talk the even number of the data, assume 1, 2, 3, 4, 5. So in this case, this is your median. Okay, first you arrange in the ascending order. We do have the data. Okay, now see, this is the final one. We have arranged in the ascending order. Now in, so how many data points we do have? 5. Okay, so this is my median. When we do talk the even number, so after 5 there is a 6. So these two value we require to consider for the median. So 3 plus 4 by 2. So 7 by 2. So 3.5. So this is the value we do have a median. So when we do have the even number of data or odd number of data, the median calculation will vary. Then talking about the third quartile, that is your Q3. So 75% of the data lies below the third quartile. Okay. So this is the first quartile. It is the 25% of a data lies below the first quartile, and Q3, that is 75% of the data lies below the third quartile. Then there is a maximum. It is the maximum value in the data set excluding the outlier. And when we do talk minimum, it is the minimum value in the data set excluding the outlier. So for the minimum and maximum calculation, we are not considering the outlier. So it is being excluded. In both places, when we have the minimum and maximum in data set, we are excluding the outlier. So here there is a one representation of the box plot. So what you can see it here, there is a lower quartile, there is a upper quartile, that is a Q3 or third quartile. Okay, so it is a first quartile, this is the first quartile, this is the third quartile, and this is the median. We are talking about Q2. Then we do have the minimum, we do have a maximum, and then this is the interquartile range IQR that we are going to talk about. IQR, so that is a Q3 minus Q1. Okay, so what is IQR? Here you can see IQR is a Q3 minus Q1. So IQR is your Q3 minus Q1. So there is a need of calculating first Q1, and then we will calculate Q3, then we have to calculate Q2, then we can calculate the other minimum, and then we can have maximum, and then we can find it out what is the outlier. Okay, so with the example, so this is the whisker we are talking, 25%, 25%. So total is the 100%. So here is the minimum value, here is the maximum value, and this is the properly distributed. It is a normal distributed, data is normally distributed. So this is the median value, and then we do have the 25, 25, and this whisker side 25, and this is the 25%. So the box plot shown here is a perfect plot with no skewness. The plot can have skewness and the median might not be at the center of the box. So here there is a no, like it is a entire one side. It is a no skewness. This is the case of the no skewness. So this is the perfect box plot. Okay. So moving on, so the area inside the box. So how much area inside the box? Taking this one. So how much area inside the box? 50%. 25 plus 25. 50% it is inside this box. Okay. So the area inside the box, that means 50% of the data is known as the interquartile range. So this is the whole thing what we have named it to IQR, that is the interquartile range. So how the IQR will be calculated? IQR, it is a Q3 minus Q1, or we can call it third quartile minus first quartile. Okay, like that. So here the outlier. So outlier are the data points below and above the lower and upper limit. So what is the lower and upper limit? How we are calculating the lower limit or upper limit? So this lower limit will be calculated. First we require to calculate the lower limit, and then we require to calculate the upper limit. And once you have the lower limit and upper limit, so the data points that are below and above the lower and upper limit, those data point would be considered as an outlier. Okay, so what is the lower limit calculation? This is calculated using this empirical correlation, and upper limit will be that. So this the first you require to calculate the IQR, that is the interquartile range. Okay, so the value below and above these limit consider outlier, and the minimum and maximum values are calculated from the point which lie under the lower and upper limit. Okay, so now once you calculate that one, then next maximum and minimum will be calculated from the point which lie under the upper and lower limit. Okay, so this is the thing. Now the same thing we can get it more creative using this example. So here the example I have taken the data one, and that comprises the following points. So I do have these points. Okay, so how many points are there? So 1 2 3 4 5 6 7 8 9 10 11 12. So total data points we do have 12 data points we do have. Now this will be arranged in the ascending order. So these are the steps. So first arrange in the ascending order. So first ascending order we are arranging this one. So this now you have this one. So first you require to calculate the median. So what is the median? We will represent by Q2. So Q2 is your median. So first the median calculation. So initially we know this data 1 is having the 12 points, and 12 is the even number. So when we do calculate the median, we require to see the middle two number. So that's the thing we have taken 120 plus 130. Okay, so here you do have the 5 point, and then here you do have the 5 point. So these two value we require to consider for the median. So median is the Q2. So 120 plus 130 by 2. So 125. Okay, this is the median. Okay. Now to find the first quartile, we take the first 6 values and find their median. So now after calculating the median, now we are going back to our calculation for Q1. Okay, so for the Q1 calculation, because we do have the 12 data point, so this whole data set we are splitting into the two part. So first part has the 6 value, and the second part is also having the 6 data point. So 6 data point. Now go ahead with the first calculating the first quartile. So we take the first 6 values and find their median. So again this 6 number is the even number. So again what you have to do it? Okay, middle two values you require to take. So 1 2 3 4 5 6. So these two value. Okay, 110 by 110 by 2. So this is the Q1. Now go for the calculating Q3. So again next 6 values we require to take. So this is from here 6 value we do have. So these two value 140 plus 150 by 2, 145 is the Q3. So now we have calculated Q1, Q2, Q3. Okay. Now IQR, how it will be calculated? Q3 minus Q1. So 145 minus 110. So that is a 35 is my interquartile value. So now you have calculated first quartile, third quartile and median value we have calculated. Now the next calculation we required, calculate the upper and lower limit to find the minimum and maximum values. So and also to find the outlier. Okay, so first we will go ahead with the finding the lower limit. So what is the formula for the lower limit? It is mentioned lower limit we do have Q1 minus 1.5 into IQR. So using the formula for the lower limit we have calculated and find the value, that is the 57.5. Now next one we will go ahead with the upper limit and we are finding the value 197.5. Now you have the minimum and maximum value, okay, between the range 57.5 and 197.5. So lower limit we get it, upper limit we get it, and in between this is the range we do have, okay, for our given data. So seeing this range, now what we can calculate? So minimum is your, here seeing the data, what is the minimum value? You do have 100, and what is the upper limit? You do have 197.5. So before that you do have the value, that is your here this is the value, and before 197 is the range. So before that what is the value? You do have 170. So this is the minimum value, this is the maximum value. So this is the minimum is 100 and maximum is 170. Okay, so we have calculated the lower limit, upper limit. Calculating this lower limit, upper limit, we do have a range. So our minimum and maximum will be between the range these two. So it will be between the upper limit and lower limit. So that's seeing that range, we can find the maximum and minimum from the data set. Now next, to find the outlier, what we are going to do, the outlier which are outside of this range, that would be the outlier. So what is my range? 57.5 or 197.5. Outside this range, but which value we do have? So go back to the, this is the ascending data set we do have in ascending order. So this is the value which is the outside the range. So this is my outlier. So the same example and calculated value we can plot on the box plot. So how we can show this? So box plot for the above calculation we are showing it here. Q1 we do have a 110, Q2 first we have calculated 125, and this is Q3. Then minimum we do have 100, maximum we do have 170, and then outside this range is the outlier. So this 120 is the outliers. Okay, so this is the thing. Okay, so that's the one thing. So what we can see it here. So this is not 25%, 25% division, we cannot call it. So IQR is this range, it's not 50%. So when we can see from the below diagram, median is not exactly at the center of the box. Okay, it is a slightly off center. So it is not at the center of the box, and one whisker is longer than the another one. So this the whisker is the longer than this one. Okay, so we also have one here, one outlier. So this is the interpretation of this box plot here. Okay, now we get this idea of the box plot. Now next, huge cases of the box plot. So what we can see it here, box plot is providing us a visual summary of the data with which we can quickly identify the average value of the data and how dispersed the data is and whether the data is skewed or not. Okay, so that is one thing. And median, what it gives us, give you the average value of the data. So this is the take here. So box plot shows skewness of the data. So if median is at the center of the box, so what is happening in that case? That was the ideal case where we do have the 25%, and here is also 25%, and this is also 25% here. So this is the thing where your median is at the center. Okay, so this is my median. So first case, median is at the center of the box. So whisker are almost the same on both ends, and the box is what? Box is normally distributed. That's the one information. When median lies closer to the first quartile, so this side is my first quartile, this is the Q1, this is the Q3, and this one is my Q2. So when it is your median lies closer to the first quartile, and if the whisker at the lower end is shorter as shown in the box diagram, then it has a positive skew, right skew. So this we can see it here. Okay, here it is a slightly uh, this lower side, your whisker is lower. Okay, so if the whisker at the lower end is shorter, so this is the shorter compared to this one. So what is conclusion here? It has a positive skew, so right skew we can call that. So if median lies closer to the third quartile, and if the whisker at the upper end is shorter, then it has a negative skew, or what we can call that left skew. So this is the box plot shows the skewness of the data, and with the position of the median we can conclude it is a normally distributed, it is a positive skew, or it is a left skew. Okay, or right skew or left skew. This is the uh, understanding about the box plot which shows the skewness of the data. So here this diagram shows box plot skewness, normally distribution, then it has positive skew, then it has the negative skew. So in case of a positive skew, this the length is a shorter, okay, and this your median is a slightly towards the quartile 1, and in this case median is a slightly towards the quartile 3. Okay, and this is quartile 3, this is the quartile 1, this is the quartile 1, and talking about this length, so this is our positive skew, this is the negative skew. Okay, now the second we are talking about the Z score. So Z score is again, this understanding is going to help us in outlier. So first we will be understanding the Z score. So Z score in statistics is a measurement of a how many standard deviation away a data point is from the mean of a distribution. Okay, so the Z score of 0, okay, it is going to be a value. Okay, so if Z score is 0, it indicates that data point's score is the same as the mean score. Okay, so if it has positive value, so positive Z score, it indicates that data point is above average, while if you have the negative score, it indicates that data point is below average. So we can see it here, there is a three value we are talking about. One Z score we are talking, it may be 0, positive, or it may be negative. So out of these three only it will lie, either it will be 0, positive or negative. So based on this value we are going to interpret that. Okay, if it is a 0, that it is same as a your mean, and then for positive and negative we do have the conclusion. Okay, so what we understood about the Z score, so it is also known as the standard score. Okay, and it tells us the deviation of a data point from the mean, expressing it in terms of a standard deviation above or below the mean. Okay, so what we are finding, it is above or below the mean. Okay, so it gives an idea of how far a data point is from the mean. Okay, so if Z score is measured in terms of a standard deviation from the mean, and take the example, if you have value 2, Z score of a 2, first of all it is a positive value, and it indicates the value is 2 standard deviation away from the mean. Okay, so this is the something we should be knowing. What does it mean? Z score 2, it indicates that 2 standard deviation away from the mean. Now how to calculate that, we will come to that one. To use a Z score, we need to know the population mean, that is a mu is required, and also the population standard deviation. Okay, so two parameter is required to calculate the Z score. Okay, so this is the formula here. To calculate the Z score for any given data, we need the value of element along with the mean and standard deviation. So when you have Z score, can be calculated using this formula. So Z score is, Z is nothing but the Z score. So here it is mentioned as a Z. So Z is nothing but the Z score. So X is what? Value of element. Then mu is the mean of the population, and then you do have the sigma, that is nothing but the standard deviation of the population. So this is the one thing. Now what another we get the Z score value, it could be positive, negative or 0. Okay, so when we will understand this concept with one example. Okay, so here is the example given. Okay, so let's proceed with this one. So assume that there is some examination where your score is a 500, and then you do have the mean score, it is a 390, it's mentioned, and we have the standard deviation, that is a 45. Okay, so now we wanted to check how well did you score on a test compared to the average test taker. Okay, so mean is given. Okay, average person they have a score near to 390, your score is 500 and standard deviation is 45, and we wanted to check our result with the other people. Okay, so how to proceed this example with the Z score we will understand. So this observed X value is a 500 and mean is 390, sigma we do have a 45. Now using the formula of Z score we have calculated Z value is 2.44. So this is the value we are interested in. Okay, here we get it 2.44. Okay, now this only tells you, okay, you get it, the your Z score is 2.44, but further it is not telling us about your score is how good, and there is no comparison we are able to get it from this one. Now we will proceeding further. So Z score is what we get it positive, that value is 2.44. Now we will make use of the positive Z table. Okay, so what is this positive Z table? So using the positive Z table, and what it tells us to know how well you score compared to the other test taker. Okay, so Z is 2.44, and what it indicates for, it indicates that data point is 2.44 standard deviation above the mean. Why? Because this is the positive value. So firstly we are going to map the first two digits. So first two digit is 2.44 on the x-axis, where in the Z table, so positive Z table we will have, okay, either from the internet or from your any statistics books. Then we will go along the y-axis and map 0.04. Then these two first go along the x-axis, then go along the y-axis, then it will intersect somewhere, and that value we require to take it and multiply by 100. Okay, so that value is cumulative probability. Okay, it is associated with the Z score value we are looking for. So let's see, this is the table. Okay, so what it is, Z positive Z table. This is the table we are talking about. So your score is 2.44. Z score is 2.44. So 2.4 we can see it here. Okay. Then we will go 0.04 is here. So go here. Okay. We reach to here. Then go down. Okay. Where it is interacting at this point. Okay. So this is the point it is interacting. Okay. So point 99266. So now we need to compare how original score of 500 on the examination compared to the average score of the batch. Okay, so what we are going to get it, we get some value, that is a your cumulative probability. Okay, now using that value, what we are going to do, that cumulative probability into 100 we are doing, then we are getting 99.266%. So what we can say, you have performed well than almost 99% of the other test taker. Okay, so this way we are using one way of using the Z score, but next we will be knowing how the Z score is going to help us in outlier. Okay, so this is our Z score. So how to interpret the Z score, we have seen Z score is 0. So it indicates data point is exactly at the mean of the distribution. Positive, negative we have seen. Positive Z score indicates that the data point is above the mean. Similarly, 1.5 means the data point is 1.5 standard deviation above the mean. Negative we have seen it. Okay, magnitude of Z score, The magnitude of a Z score shows how far away the data point is from the mean. Okay, so larger absolute value of Z score indicates that the data point is farther from the mean, and while the smaller absolute value indicates it is a closer. Okay, so this is our we are talking about the Z score. So there is some common threshold. So Z score greater than 0 or less than -2. Okay. So often considered unusual or significant, indicating the data point is more than 2 standard deviation away from the mean. Similarly, it is for the 3 Z score greater than 3 or less than -3, typically consider an outlier. So Z score value here we are correlating with the outlier. So calculating this value will gives the idea of the outlier, and when we have the outlier information, we are able to make it out, identify the data point which is a outlier from the Z score calculation. So that suggests that the data point is extremely far from the mean. So this is the common threshold with respect to the Z score. So property we have already talked about. Okay, so this the magnitude of a Z score reflect how far a data point is from the mean. Okay, in terms of the standard deviation, the positive, negative, this understanding we do have. Okay, now here you can see it. It is a normal distribution things have been given. At the center you do have a mean. Okay, and then you do have this standard deviation. So this the left side you have the positive positive. Okay, so 1 mu plus 1 standard deviation, 2 standard deviation. So this is how far is from the sigma is the standard deviation. So this is the point we are taking. It is far 1 standard deviation from mean. Okay, this is 2 standard deviation, this is the 3 standard deviation. Similarly this side. Okay, so this is the we do have a 68 to 99, 68 to 99.7 rule, we can call this one. Okay, rule for the normal distribution. So it is empirical rule in the your normal distribution. So when we do talk about, now we see how this outlier we are going to calculate using the Z-score value. So we can calculate outlier in the data using the Z-score value of the data points. Okay, so the step to consider an outlier point. Okay, so first we gather the data set in which we want to see the outlier. So first of all we should have a data. In the data what we want to check this out. Okay, is there any outlier present or not? So we will calculate the mean. Okay, and standard deviation of the data set. Okay, so first calculate these two values, because when you use the Z score you require the mean and standard deviation. So these two parameters are required, statistical parameters are required. Okay, so these value will be used to calculate the Z square value of each data point. Okay, what we are doing in the previous example, only we wanted to compare with the one result. But when we go ahead with the data set, what we want to calculate the Z score value for each data point. Okay, so with respect to the value obtained for the Z score, then that point will be considered, okay, it is inside the range, or it would be considered as an outlier. Okay, so that we will calculate the Z score value for each data point, and the formula we are using the same which we have used previously. Z is equal to x minus mu by sigma. So this x is will be the data point, mu is the mean of the data, and sigma is the standard deviation of the data set. Okay, so we will determine the cutoff value for the Z score, after which the data point would be considered as an outlier. So this is not given by default. We require to determine the cutoff value. Okay, so that's one thing. So it does depend, this cutoff value is a hyper parameter that we decide depending on our project. Okay, so a data point whose Z score value is greater than 3. Okay, it means that the data point does not belong to the 99.73% of the data. If you see this one, so till here we do have the 99.7%. Okay, this side. Okay, so if we are considering, okay, till here if you analyze this figure. Okay, so this is the mean. What is the point we do have? This is the 68.27. when we do talk about this one, this is the one, this is at the center. Okay, when we will go to the first standard, This is the value. We do have 68.2% of data. When we go to the second standard, we do have the data 95.45%. When third standard, then we do have standard deviation, then we do have the 99.73. Okay, so it is like that. In relation to the previous diagram, so a data point whose z-score value is greater than 3 means, what it means, the data point does not belong to the 99.73 data point of the data set. Any data point whose z-score is greater than our decided cutoff value will be considered as an outlier. So this is the our z-score. Now, why use z-score for outlier detection? Okay, z-score is useful for detecting outlier in normal distribution as it highlights data point that lies far from the mean. Okay, the second normal distribution is shown below, and it is estimated that 68% of the data point lies between plus minus 1 standard deviation. This already I explained you. Then the second one, 95% of the data point lies between plus minus 2 standard deviation. So this is the second, and the third, 99.7% of the data point lies between plus minus 3 standard deviation. Okay. This is particularly for we are talking about the normal distribution. Okay. Now another method for outlier detector, that is a interquartile range IQR method. So IQR calculation we have seen it where in our box plot. Okay. So the same concept applies here. You require to calculate the first quartile, then you require to calculate the third quartile, and IQR will be Q3 minus Q1. So this is IQR is a interquartile range method. It is a widely used and reliable technique for detecting the outlier. It is a robust to skewed data and help identify extreme values based on the quartile, and it is most trusted approach in the research field. Okay. So IQR, how it would be calculated, we have seen it. This is the panda side, so that's the syntax part. Okay, so anyway we are going to talk about this syntax and through the coding. Okay, so we can skip currently this one. Now talking this visualization and removing data using the scatter plot. In the plotting in Python, we do have the idea of the scattered plot. So scattered plot also helps in analyzing the point which can be considered as an outlier. So here scattered plot helps visualize relationship between the two variables. Okay, so here just one example I have been put it here. One figure, using the figure we can get it. Here there is a x-axis and there is a y-axis. So one at the density of oil, and then we do have the other parameter, that is H2S concentration. Okay, so what this data point, it is just showing some of the data point is out of the range. If you will see this green one, all is clustering around this only, but this the one green point, it is out of this cluster. Similarly, if we take this the other color, okay, it is a outside from this one. This way, seeing this scatter plot, we can find it out, okay, which data is outside the cluster. So it is used when we have the paired numerical data and when our dependent variable has a multiple values for each reading independent variable. So outlier appears as a point far from the main cluster of the data. That we can see it, seeing this one example here. Okay, now we have reached to the last one. Okay, so we can conclude it here. In the today's discussion, we do talk about detecting the outlier. Okay, so first we get the understanding of the box plot, then we get the idea of the z score, then we do talk IQR, interquartile range method, and finally we have the understanding of the scatter plot. This is all about the today's discussion. See you in the next class. Thank you.